Hi, welcome back to part 2 of the meditation app. Let's review quickly what we did in the previous episode. If you haven't seen the video yet, I'll link it in the description below. What we have achieved so far was mounting our UI, arrange some data, pass it to the views, and showcase them properly. Still, we haven't taken care of the audio playing yet, which is the whole purpose of this app. We'll be able to do just that with Apple's framework AVKit and managing all of its functionalities in one place. Let's get back to Xcode. Create a new Swift file under Meditation View Model. Name it Audio Manager. Import AVKit. Create a final class, Audio Manager. Then add a variable player of type AVAudioPlayer. It's going to be optional. Next, we're going to activate the audio player. Create a method, startPlayer, that's going to take track as the argument of type string. First, we're going to get the URL of the track by finding the resource in our project. Let URL equal to bundle.main.url for resource with extension. The resource is the track and the extension is MP3. Then call the AVAudioPlayer with contents of URL. As you can see, the auto-completion indicates that it can throw. So therefore, we need to wrap it in a do catch block and cut this, paste it here. In a do catch block, we need to try to call the expression first. This is going to be the URL, and we'll assign this to the player. In the catch block, we'll print the error. Fail to initialize player. Error. If you option click in the URL, it says that it's an optional. Therefore, you have the option to force unwrap it, like this. However, let me tell you, it's not wise. If you run the app like this and you can't find the track, it's going to crash. We can test it out very soon. Let's end this function by calling play. Player.play. The question mark stands for optional chaining. It's fine to leave it like this because if there's no instance of player, it's supposed to jump to the catch block anyway. To attempt to play audio easily, let's turn this class into a singleton that will allow any views, classes, and structs to access it. Singleton is a common pattern for making sure there's only one instance of the class. Just initialize it statically. Static let shared equal audio manager. In the player view, add the onAppear modifier to the Z stack. onAppear. And call the start player method audio manager dot shared dot start player and pass the track meditation vm dot meditation dot track. Now you can run the app. Click on play. As expected, it's crashing because we haven't added an MP3 file to the project yet. Fatal error. Unexpectedly found nil while unwrapping an optional value. To prevent an unpleasant user experience, if the app is unable to load or find the audio file, turn this into a guard statement. guard let URL equal to all of this. Else, if that's the case, we'll print a clue for us. Resource not found. And we'll print this variable track. And then we'll return. So the URL now is not optional anymore. And we can remove the exclamation mark. Run the app again. This time it will exit the function and we'll see the error message in the console. Resource not found, meditation 1. No crash. Isn't this way preferable? Indeed, there isn't any MP3 file in the bundle. Time to add it. You can add any MP3 file on hand to the project. If you don't have any, you may go to upbeat.io to download one for free. As for me, I'll use a song that my partner produced for me just for this course. He's a music producer. Thanks, Ricky. By the way, he has the rights to this song, so just to be clear, no commercial use. I'll drag and drop under the Assets folder. Make sure to select Copy Items if needed. Now, is the track name in the meditation data the same as the MP3 file? Yes. So we're good to run the app again. You hear that? Finally, we're able to hear the audio. Don't worry about this message, no factory registered for ID. If the app is tested on a real device, it wouldn't be there. In the simulated device, if you lock the screen, the audio just gets buggy. The same applies if you close the app. On a real device, it simply stops playing. To allow background playback, we need to enable the background mode capability in Xcode. Select your project and then your app's target. In the Sign In and Capabilities tab, click on Add Capability, choose Background Modes, and select the Audio, AirPlay, and Picture-in-Picture mode. We can run the app again. Play. This time, if you turn off the screen, or close the app, you can hear that the music keeps playing. Great! The other issue that blocks audio is the silent mode, this button. But you can only check it out on your real device because it doesn't work on the simulator. Let's go back to Audio Manager. To let the audio work even if the device is on silent mode, we're going to add a few options to the audio session. Here, try AVAudioPlayer.SharedInstance.setCategory. The category is Playback. The mode is default. No options. Playback lets your audio ignore the silent switch and play by itself, muting other audio. The default mode only includes audio not involving any recording, video, or chat. At the same time, we're also attempting to activate the session just in case the session fails for whatever reason. Try AVAudioSession.SharedInstance.setActive to true. And again, no options. Actually, if you go to player view and your preview is on, the music would start playing automatically. This is going to be annoying during development. I'm going to tweak this to shut it up. In the start player function, add an isPreview argument of type bool and default it to false. Instead of playing right away, we will prepare to play if the preview is true. If is preview, prepare to play, player.prepare to play, else, then we're gonna play it. Back to player view, we will add a prop is preview, var is preview of type bool equal to false again, and we'll pass that prop when calling start player. Is preview is preview. In the preview, set it to true though. Now resume. We shouldn't hear the music anymore. Seems to be working. This method proves useful if you want to configure differently for the preview. We managed to play audio by simply retrieving the single shared instance of Audio Manager. You may choose to keep it that way and just call it a day. However, Singleton is considered an anti-pattern in the developer community. Even though it can be easily accessed, it has certain pitfalls. Not only it is mutable, but global accessibility can render the app unsafe. Rather, only parts of the app that need it should have access to it. Moreover, I want to integrate states later on and force the views that use it to automatically update themselves, and forget about unit testing with Singleton. The alternative solution would be dependency injection. Thankfully, Apple provides us the Combine framework that we can take advantage to pass dependencies around. In my opinion, Combine is crucial to any SwiftUI project in managing global states. It is similar to the Context API in React. Simply make Audio Manager conform to observable object. We don't even need to import Combine in this case, as observable object is already included in Foundation. See? Recall that we also did this in the meditation view model. We can comment out the shared property now. Since we still want to keep Audio Manager as a single instance, just initialize it early on in the app. A great place is where the app is initialized. Add a state object property and initialize Audio Manager. Add state object var Audio Manager and initialize Audio Manager. An instance of it will be created on app launch. To pass down the dependency to all its child views, add the environment object modifier to the content view. Audio Manager. SwiftUI will reserve a separate storage for that class and let any child view retrieve it via the add-environment-object property wrapper. We can go ahead and do exactly that in the player view. Add environment object var Audio Manager of type Audio Manager and scroll down. Here, copy this, comment it out, and instead of accessing the shared instance that doesn't exist anymore, we're just going to use the Audio Manager from the environment object. Notice that since Audio Manager is not being used in meditation view, we don't need to fetch it there. As you can see, the structure also prevents prop drilling. If you look at the preview of the player view, notice that the preview status indicator is going to change to red. Since we switched things up, the player view now became depending on the environment object audio manager. Besides, bear in mind that the preview is always a separate entity from the app. For that combined reason, we need to pass the environment object modifier to the preview as well. Environment object audio manager. That should fix the preview. The other point to note is that any view that the player view is a child of, we're also required to do the same. They are the meditation view and the content view. So go to the meditation view. The previews will crash if you ever try to get to the player view, right? See. So here also add the environment object, audio manager. Last but not least, do the same thing for the content view. All that's left to do is to turn the control buttons in the playback view into actionable items. Additionally, we'd like to see the timeline bar move as the track progresses, along with the counter of the current and remaining time. We will also let the user drag the playhead in the timeline bar to change the current time of the audio. First and foremost, we need to observe the change in time and notify the view to update itself. We can make use of the timer publisher. It's a publisher that repeatedly emits the current time on the given interval. Let timer equal timer. We'll tell the timer to publish every half a second on the main thread and in the common loop. We'll remove the options and the tolerance. Then let it automatically connect right from the start. The view can subscribe to its notifications with the onReceive modifier. On receive, the publisher is the timer. In the callback, we will need the value of the current time. And what we want to do is to make sure there's an instance of player beforehand. Guard, let player equal audio manager dot player, else return. Then update the value of the slider with the player's current time. Value equal player dot current time. Run the app. Play. And you can see that the slider advances by every half second. Very nice. This is the first step in the right direction. Previously, we plugged in constant values for the duration, the current time, and the remaining time, as we had no way of knowing those values. Now we're able to read those values from the player itself. Let's try to change the original 60 seconds to the player's audio duration. Audio manager dot player dot duration. But because the player is optional, we're always required to provide the default value if it's nil. And based on our previous tests, we can already cross out the force unwrapping option as suggested by Swift. Knowing that this is not the only playback component that relies on the player instance, it's going to be a problem. Who wants to constantly set a fallback value? So we should wrap the whole playback in a conditional statement based on whether or not there's an instance of player. So wrap this in if let player equal to audio manager dot player. open braces. We're going to shorten out the V stack and the H stack because we're going to wrap both of them in the if statement. And open it back. We're going to make sure to re-indent all this code with Control-I. Now we can directly extract the player.duration, remove the question mark and the default value. And we don't have to worry about coalescing defaults anymore. Shorter and sweeter. This is called optional binding and is part of the basic concept of Swift. It's very common to see that in a Swift project. Now let's run the app. Play. The change in duration is not apparent, but it's there. Now let's try to drag the slider. It'll inevitably fall back to the current playing time. While we're on the slider, let's take care of this issue. What's missing is updating the player's current time upon dragging it. If you option click on the slider, it says that we can supply the unediting change closure to the slider and it will return a boolean with the value of true when the user starts moving the thumb and false when they stop. So let's do that. Editing in. We only need to update the current time with the slider value once the drag action is over. If is not editing, then the player dot current time is equal to value. And let's print the editing value to see if it's live. Print. Editing. Editing. Let's run the simulator. Try to drag the slider. You see, while dragging, the editing value is true, and when you release it, it's false. This time it sticks. However, it's not smooth sometimes. We can re-indent this line. The reason the thumb jumps back is that while we move the slider, the value is also updated every half a second. On one hand, we're updating the current time from the value. On the other hand, the value from the current time. So it's clashing against each other. What we can do is to prevent updating the value while we're dragging. So add a private state. At state private var is editing of type bool equal to false. The state will capture it if we're dragging or not and will be updated from the slider editing value. Here is editing equal to editing. In the unreceived closure, add to the guard statement the condition that this new state is not in editing. Not is editing. Let's run the app again. Try to drag the slider. The annoying glitch should disappear by now. The timeline bar is reflecting the audio's current time as seconds pass, but we can say the same for the two timers right under it. Remember that we create an extra static method as an extension to date components formatter for showing time intervals in timer style and will be used later. Well, let's call that positional method for the current time and the remaining time. Go to playback time, and in the first text called date components formatter, dot positional dot string from player dot current time, and it's going to ask for a default value, so I'm going to set that to 0:00. Same thing here, date components formatter dot positional dot string from, this is the remaining time, so it'll just be the player duration minus the player current time. Again, let's default this to 0. Let's run the app. Look at that, the timer is running. Good, let's move on the buttons, starting with the play pause button. Indeed, it'll serve as both functions. Let's go to the audio manager and create a new method for this purpose. Func play pause. Once more, we'll guard for an instance of player. Guard let player is equal to player, else. We can print a message in the console if there isn't. Print instance of audio player not found and return. Next, if the player is playing, let it pause. If not, let it play. If player dot is playing, player dot pause, else player dot play. Back in player view, call it in the action closure of the play pause button. Audio manager dot play pause. Not only that, we'll show the correct icon according to the playing state. Is the player is playing? If so, show the pause dot circle dot fill icon. If not, show the play dot circle dot fill icon. Actually, this should be a colon. Let's run the app. Play. You can see that the button displays the pause icon initially. Click on it and it switched to the play icon, and so on. Notice there's a little delay in the icon refresh. That is due to the fact that this view is only updated on every 0.5 seconds. But ideally, we want an instant refresh. How to? Go to Audio Manager and add a new state for is playing. Private set var is playing. Type bool and default it to false. This is why I rather make it an observable object instead of a singleton. We'll prefix with the property wrapper at published to notify the underlying views of its changes. Let's print when it has set a new value with the didSet observer. DidSet print is playing is playing. In this class, we'll update the isPlaying state accordingly whenever we call play or pause. Here, for 1, is playing is equal to true. Here is playing is equal to false. Finally, is playing is equal to true. Meanwhile, the button system name should be contingent on this new state instead of the player one. Go to player view. Instead of the player, we'll do audio manager is playing. Run the app again. If you click on the pause button, you can see it's an instant refresh. Now click on the close button. Bummer, we can still hear the music. Let's address this next. We'd like for the music to stop playing when the user either clicks on the stop or the dismiss button. In Audio Manager, let's create another method for it. Func stop guard let player equal player else return. If the player is playing, stop it, and we'll set the is playing state to false. On the dismiss button in player view, call this function right before the dismiss action. Audio manager dot stop. We can replicate these actions for the stop button also. Ready to run the simulator and test it out. Let's try to click on the dismiss button first. That's good. The music stops playing for sure. I guess we could have called the stop function on the disappear modifier of the player view too. Here, on disappear. However, the outcome would be the same since these are the two buttons that would make this view disappear. What comes next are the backward and forward buttons. It's quite straightforward actually. For the backward button, just remove 10 seconds from the player's current time. Player.current time minus equal 10. As for the forward button, well, add up 10 seconds instead. Player.current time plus equal 10. It's easier this way than having to create and call a function. You can easily check this out in the preview. It's working. Last but not least, let's activate the repeat option to replay the track in a loop. We will need a Boolean state to capture the looping. We can either add it to the player view and have it reset when it dismounts, here, or add it to the audio manager and have it persist. It's up to you. I'll go with the latter choice. Add published, private, set, var is looping, bool equal to false. Then create a method to toggle the looping behavior. Func toggle loop guard let player is equal to player else return. Now we're going to switch the player number of loops between 0 and 1. Player.number of loops equal player.number of loops. Is it equal to 0? Then set it to -1. Else, set it to 0. So setting the number of loops to -1 make it repeat forever. As a result, the isLooping state becomes true if it's not 0. IsLooping player.number of loops not equal 0. Let's print that. In the action closure of the repeat button in player view, we're going to call the toggle loop function AudioManager.toggle loop. Also, let's change the icon color when the looping state is true. Let color of type color equal to AudioManager.isItLooping. Make it teal, else make it white. Then we can call that additional parameter color. Let's run the app for the final time. Yeah, it restarts. Okay, now if we turn off the looping, when the song finishes, it's not gonna play it again. That's awesome. Alright, this wraps up the audio playing functionality as well as the whole app. I hope you have learned many new things that could serve you in the future. If that's the case, please like and subscribe so we can provide you with more content like this. Adios!